Hi, Assalamualaikum. So now we are going to discuss question from textbook, page 74, self-exercise 2.15. Okay, all these questions involve small change and approximation. Okay, now question number 1. The period of oscillation T second of a pendulum with a length of L centimeter is given by T equals to 2 pi square root L over 10. Find the approximate change in T. So meaning that delta T. Okay, delta T. When L increases from 9 centimeter to 9.05. Okay, here we have delta L. Delta L final value 9.05 minus 9 is 0.05. Okay, here we have T in terms of L. We try to differentiate, but before we differentiate, we simplify first. This one become 2 pi over square root 10. L power of 1 over 2. So then we differentiate T with respect to L. So dt dL equals to 2 pi over square root 10. So then 1 over 2 L power of negative 1 over 2. Okay, this one we can simplify. Become 1 over, pi over square root 10 L square root 10 L. Okay, so now we substitute L is from the given value. L is 9 initial value, so pi over square root 10 square root 9. Okay, this one equals to pi over 3 square root 10. Okay, so now we are going to find delta T. Okay, a small change, approximate change of T. So delta T. So we have relation here. So delta T, delta L approximate to dt dL. So delta T equals to dt dL times delta L. Okay, dt dL is just now pi over 3 square root 10. So delta L is 0.05. Okay, so for this one, we just press calculator. We get 0.005270 pi. Now question number 2, the area of a drop of oil which spread out in a circle increases from 4 pi centimeter squared to 4.01 pi centimeter squared. Okay, here given area. Okay, area increases, this one given the info. So you can identify delta A equals to 4.01 pi minus 4 pi, which is 0.01 pi. Okay, so this one is a circle. Okay, area of circle. So area of circle is, formula area of circle, pi r squared. So equals to 4 pi. Okay, so 4 pi, because 4 pi is initial value, so r squared equals to 4, then r equals to 2. Okay, so then we have A in terms of r, we differentiate, we get dA dr, which is equals to 2 pi r. Okay, then we substitute r equals to 2, so dA dr equals to 4 pi. Okay, now we are going to find the small change in radius. Okay, so meaning that delta r. So then we have a relation here, delta r, delta A approximate to dA. Sorry, dr, dA. So dr, dA, dr, dA. Okay, delta r equals to dr, dA times delta A. dr dA, here we have dA dr, we need dr dA oppositely, so 1 over 1 over. Okay, so here the value is 1 over 4 pi times delta A just now 0.01 pi. Okay, so we simplify, we get 0.0025. Then number 3, the length of the side of a cube. Okay, so cube, we draw a cube all same size, the side. Okay, so side are x, x, x. Okay, find the small change in volume. So meaning that you are going to find delta V. When sides increases, just now side is x, so side increases, so delta x. Final 1.99 minus initial 2, so negative because decreases 0.01. Okay, so here we have volume. Formula of volume for cube is x cube. So differentiate, we get dv dx equals to 3x squared, and x equals to initial is 2. So 2 squared equals to 12. Okay, so we are going to find delta V. So delta V, delta X approximate to dv dx. So delta V equals to dv dx times delta X. dv dx is 12 and delta X is negative 0.01. Okay, so here we get negative 0.12. The last one, question number 4, find the small change in volume. Okay, here small change in volume, delta V. Okay, so of a sphere, when the radius decreases from 5, radius decreases from 5 to 4.98. So delta R equals to 4.98 minus 5, which is negative 0.02. Okay, so we have volume of sphere. Formula of volume is 4 over 3 pi r cube. So dv dr is 4 pi r squared. We substitute, r is initial, which is 5 squared, equals to 100 pi. Okay, now we are going to find delta V. So we use the relation delta V, delta R approximate to dV dr. So delta V equals to dV dr times delta R. dV dr is 100 pi. So delta R is negative 0.02. So the final answer will be negative 2 pi.